In this video we're going to look at the Lowry-Brønsted model for acid-base theory. It's more widely used in chemistry and it was developed independently by two different scientists, Nicolaus Brønsted in Denmark and Thomas Martin Lowry in England. And it basically tells us that an acid substance contains the H+ ion or a proton. And the idea is that protons are transferred in an acid and base reaction. With this theory it's found that acids are proton donors and that bases are proton acceptors. With this model, if we take the ionization of hydrochloric acid into solution, we have to show hydrochloric acid reacting with water, and this forms H3O+. Now H3O+ is the hydronium ion, and it also forms the chloride ion. In this, hydrochloric acid is acting as an acid and it donates a proton to the water. As the water is accepting the proton, it's acting as a base. Similarly with a base, if we take the weak base ammonia and react it with water, we have to use a double-headed arrow this time to show that the reaction is reversible as it's a weak base. We form the ammonium ion and our hydroxide ion. Now as you can see, ammonia is a base. It accepts the proton from water. That means that water is acting as an acid. This forms the ammonium ion with the hydrogen proton from the water, leaving the hydroxide ion. Another example is for the hydrogen carbonate ion, HCO3 negative. The hydrogen carbonate ion is basic as it comes from a metal hydrogen carbonate. If we then were to react this in water, we find that we make carbonic acid and we make the hydroxide ion. From this we can determine, as the hydrogen carbonate gains the proton, it is our base. As the water loses the proton and donates it to the hydrogen carbonate ion, it is our acid. This means to say that the carbonic acid now could potentially act as an acid. So this is now our conjugate acid. The hydroxide ion is basic and is known as the conjugate base. These are the species that are made from an acid-base reaction. And there is the spellings in full. So the conjugate acid is formed after a base receives a proton and it can potentially act as an acid. Similarly for the conjugate base, it is able to accept a proton and therefore potentially act as a base. One more example of this would be between the hydrogen sulfate ion and water. Now hydrogen sulfate comes from sulfuric acid, so during this reaction it will react as an acid. If the hydrogen sulfate reacts as an acid, it will donate a proton, therefore we will make the sulfate ion and the water will become hydronium. The hydrogen sulfate acts as an acid, the water acts as a base, the sulfate ion now can accept protons, so becomes our conjugate base, and the hydronium ion can donate a proton, so becomes our conjugate acid. Substances that can act as either an acid or a base, such as water, are known to be amphoteric. This also includes compounds and the metals aluminium, zinc, and chromium.